Okay, 2.6 and 2.7, rational functions, day 2. Let's go ahead and finish up our notes in our packet. And so, let me just check the time again. Yep, we're going. All right, so we're going to graph, once again, it's a rational function, but we're going to graph something that looks a little bit different than those first 2 samples that we did. So let's go ahead, because it's a rational function, right? We've got x in the denominator. We're still going to find our vertical asymptote first. So we take the denominator, we set it equal to 0, and we subtract 1, and we see that we've got a horizontal asymptote at x equals -1. So we go to the x-axis, we find -1, and we put our, why do I keep saying horizontal? Vertical. This is, I'm drawing a vertical. I'm like, I just said horizontal. This is our vertical asymptote. Ay. This whole talking and writing thing, multitasking. All right. So step 2 is about finding the horizontal, finally, the horizontal asymptote. And so remember how we have 3 different things that could happen when we're finding horizontal asymptote. So as a reminder, let's look at our steps. So we've already done this one, right? Highest powers are equal. Then the horizontal asymptote is the ratio of leading coefficients. We already done that one. Bottom power is the highest. We've done that one. It doesn't matter how much higher. If it's higher, the horizontal asymptote is y equals 0. So we've done that one. This is the one we're going to do now. The top power is the highest, which means there is no horizontal asymptote. And you may think that's a good thing, but actually that makes graphing a little bit harder. So there's no horizontal asymptote. So we're going to say, whoop, we're going to say no horizontal asymptote. All right, now, every time we say no horizontal asymptote, we have to ask ourselves, wait, could there be a slant asymptote? Did you even know there was such a thing? We've got vertical asymptotes, we've got horizontal asymptotes, and we have slant asymptotes. And they're just like what you'd think, right? They're at a slant. And so how do we know if we have a slant asymptote? So let's see. Always check for slant asymptotes. If there's no horizontal asymptote, if the denominator's highest power is exactly 1 more than the numerator's highest power, then we have a slant asymptote. That is backwards. That does not make sense. I think I wrote that backwards. The numerator. Yeah, let's correct that. If the numerator's highest power, not the denominator. So we'll cross through that, because this should be the numerator, and that should be the denominator. There we go. Do not know what happened there, but that's okay. We can fix our mistake. All right, always check for slant asymptote. There's no horizontal asymptote. If the numerator's highest power is exactly 1 more than the denominator's highest power, then we have a slant asymptote. And so divide to find it. So let's go and look and see if we've got this. So is our numerator exactly 1 more? Is 2 exactly 1 more than 1? It is. So that means our new thing for today, we have 2 new things today, and one of them is this. We have a slant asymptote. All right, to find slant asymptote, we have 2 choices. We can do long division or synthetic division. And since synthetic division is faster, let's do that. You can always do long division if you wanted to. So if what I'm dividing by is x plus 1, what do I put in the box? Who's the queen? -1, right? And then we have to be careful. We only have 1 coefficient here, right? Because we just have x squared. But we need to write the coefficient for x and for our constant. So it's like we're writing, instead of x squared, we're writing x squared plus 0x plus 0. We have to have that, or synthetic division isn't going to work. We have to have coefficients for everything all the way to where we get to the constant, and that's where we stop. All right, so let's go ahead and drop the 1 and multiply and add and multiply and add. Now here's the thing. We don't care that we have a remainder in the remainders box. We're going to totally even ignore this. We don't care about that. What we do care about is what's left here. This says 1x minus 1. Yes, I could have written x minus 1, right? This is our slant asymptote. That is our slant asymptote. So what we're going to do is we are going to graph that line. And so when we think about, okay, we're good. So when we think about this as a line, right, y equals, this says my y-intercept is -1, right? So we go to the y-axis, we find our y-intercept of -1, and this one says the slope is 1, so that means up 1 over 1. I'll do a couple of up 1 over 1s and then get a good, oh gosh, I can't connect those with the solid line. It's a slant asymptote. All right, whoop, that didn't look good. All right, so let's connect them with the dotted line. So we've got a slant asymptote. This is actually a wonderful thing because without the slant asymptote, all we'd work with is a vertical asymptote, and we would just have to put a lot of numbers in the table to see what this rational function's doing. All right, so let's go ahead and keep going. We do need a table, right? I'm going to go ahead and make these be a little bit smaller. All right, so we are going to make a table, and we're going to see what is happening. I'm not sure where that arrow went to. All right, we'll just get rid of it. All right. So we've got our vertical, horizontal, we've got our vertical asymptote, we have our slant asymptote, and we really want to know where is our graph. Is it going to look like this and this, or is it going to look like this and this? Because it's going to be one or the other, right? So let's find out. All right, let's get rid of what I just did. All right, so let's make a table and find out. So step 4 is making a table. And I'm going to pick something on either side of the vertical asymptote. So let's see, the vertical asymptote's at x equals -1, so I'm going to pick -2, and I'm going to plug that in. What are we going to get? We're going to get 4 over -2 plus 1 is -1. So -4, right? Let me double check. 4. Now I'm not trusting myself after writing my horizontal asymptote all the time for vertical asymptote, but that's okay. So that's a 4 and a -1, so that is a -4. And so we're going to go ahead and put that -2, -4. So now we know, this part. And once again, it's just a sketch. We're not being perfect. And then we want to know what's happening at 0, right? On the right side of the vertical asymptote, 0 is a good number to pick. And so when we plug 0 in, we're going to get 0. You know what? Did I skip finding my, I skipped finding my x-intercepts, didn't I? Well, if we found our x-intercepts, we would have just stopped and said, wait, let me finish this. Okay. So if I would have included that in my step, my x-intercept, I would have done what? I would have set x squared, the numerator, equal to 0. And then we got x equals 0, which is why we bounced off at 0, right? We have an even multiplicity, so we bounced off of that 0. And of course, whenever we have 0 for the x-intercept, that means that our y-intercept is also 0. Okay, woo! Our new thing was finding that slant asymptote. And whenever we look for that, whenever there is no horizontal asymptote, and there's no horizontal asymptote every time the power in the numerator is greater than the highest power in the denominator. All right, so I'm not going to fill these in because you all can do that. We did holes yesterday, I think, or I'm sorry, the last lesson, but there's no holes here. You can fill the rest of it in. I'm going to keep going. So we've got another, there's our steps. Okay, so we've got another one. And let's see, let's do our first step. First step's always find that vertical asymptote, right? So we set our denominator equal to 0. Now, here's the deal. I could do this like this. I could say x squared equals 1 and x equals plus or minus 1. There's nothing wrong doing that. But it's going to make me not see that actually one of these is not a vertical asymptote. So instead of doing it that way, I'm going to factor. It's a difference of two squares, right? So I'll have x plus 1, x minus 1, and so then I'll have x plus 1 equals 0, x minus 1 equals 0, so I'll have x equals negative 1 and x equals 1. It looks like we have two vertical asymptotes, but every time I have my vertical asymptote, I find it, I want to stop and look up at our function and say, can I simplify this? And we can, right? Because we've got the difference of two squares in the denominator. So when we rewrite it as x plus 1 over x plus 1 times x minus 1, we see that our x plus 1's cancel out. So that means that the vertical asymptote that came from the x plus 1 factor, that's actually a whole. And so we did this, right? I can't remember what the last lesson was. I videoed it yesterday and it's gone. I can't remember if we covered that or not. And so this is a whole. So here's what that means, and we're going to learn more about that when we do calculus. Sometimes, for real, there's no value for this function when x is equal to negative 1 and x is equal to 1. That is undeniable, all right? But the difference is how we show that in our graph. Here for x equals 1, right, when x equals 1, it's going to be undefined, right, because we'll have 0 in the denominator. X equals 1 is actually a vertical asymptote, right? And that shows that there is no value for this function when x is equal to 1. So that's our vertical asymptote. Now, this is a whole. And we're not going to go to negative 1 and put a hole in there. No, we're not going to do that. That's not what it means. What it means is once we sketch our graph, we're going to come back to where x is equal to negative 1. We're going to look up or down wherever our graph is, and we're going to make a hole in the graph. Because when we plug negative 1 in for x, that's going to give us 0 in our denominator. Okay? Okay. So we've got a vertical asymptote. We've got a hole. Let's see. Let's go ahead and move on. Man, I write so big. I don't have any room to find anything else. So I guess I'm done. Let's see. Let's find our horizontal asymptote in just a second. Okay. So step 2, let's find that horizontal asymptote. Let's do some pink. Okay. So step 2, we're going to go ahead and look at our rules, right? So it's not the first rule where our highest exponent and then both the numerator and the denominator are the same. Nope. It's our second rule, right? Where the highest power in the bottom, right? The bottom power is the highest. We have our horizontal asymptote at 0. And so we're just going to say y equals 0 as our horizontal asymptote. I love that. We don't have to do any work, do we? We just have to come here and put our horizontal asymptote at 0. All right. We're not looking for a slant asymptote because there's a horizontal. If there's not a horizontal, that's when we stop and go, wait a minute, is the numerator's power exactly one more than the denominator's power? Because then we have slant asymptote. But not now. We have a horizontal. Yay! All right. I'm not going to skip finding my zeros this time. Sorry, I skipped it last time. Let's do that pink. So let's do step 3. Let's find our zeros. And so we set the numerator equal to 0. So we know we have an x-intercept at negative 1. Let's go ahead and put that in. Okay. And then let's find our y-intercept. Our y-intercept comes from making all the x's equal to 0. So we'll have what? 1 over negative 1, which is negative 1. So that's our y-intercept. So we'll go to the y-axis, and we'll put a negative 1 there. And then you're like, Miss Overby, we cross through the, we're crossing through the horizontal asymptote. What's going on there? Okay, we're going to see what's going on there in just a second. All right. Let's go ahead and make our table so we can just sketch it. What color haven't I used in a while? I'm going to use, ooh, how about that? Like burgundy. All right, so here we go. Let's make a burgundy table. Step 4. We will come back and see what's going on there, why there is a dot at -1. But I think some of you can already see that. Hint, 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 right? All right, so let's do -2. Let's make sure we know what our graph is doing there. So let's see, in the numerator, that's going to be what? -2 plus 1 is -1. In the denominator, that's going to be 4 minus 1 is 3. So it's a -1/3. So we're going to be -2, -1/3 is right about here, right? And let's just put a -3, see what's going on there. So -3. We're going to have what? -3 plus 1, that's -2 on the top. And then that's going to be 9 minus 1 is 8, so that's a -1/4. So that's a little bit smaller. It's really doing, let's see, it's going up a little bit. So we are hewing. That's really interesting. What we're going to do. It really looks like this. Let's do this. We're going to completely ignore that -1 as the x-intercept. So let's come back to where we saw this. See how we saw x equals -1 as x-intercept. And we were right to put it on the graph because that's what we do. And then we look at the graph and see what's going on after that. We know x cannot equal -1, right? If x equals -1, we've got 0 in the denominator, right? Because -1 squared minus 1, that's 0. And we can't have 0. So we do not have an x-intercept at -1. So let's go ahead. I'm going to use my teeny tiny eraser, not obviate. I don't know if I'm pronouncing that right. Let's see. All right, so we got rid of that. Now, but that's not all we have to do. Okay, because we're coming back and we're realizing, wait a minute, we've got a hole at x equals -1. So what that means is we are going to be a little teeny tiny person, and we're going to walk on the x-axis, and we're going to look at -1, and we're going to stand on -1, x equals -1. So wait, let me write us there. Here we are. We're a teeny tiny person. So let's see if I can get that. We're a teeny tiny person on -1, and we're looking down, and we're like, uh-oh, there should be a hole there, and there's not. All right, so we're going to put a hole in the graph right there. And I know this is something that I think goes better when I can actually see you and you can ask me questions. So if you're learning through the video, make sure you ask me when you see me in class. So I'm going to put a little hole. There we go. All right, that's a little bit bigger than I wanted, but that's okay. Let's get the burgundy back. I'm really liking this burgundy. Why don't I use it more often? All right, so let's put a hole right there. There we go. All right, so we got that part of the graph done. And then let's test on the right side of the vertical asymptote. Let's test 2. And when we plug 2 in, we're going to have what? 2 plus 1 is 3. So we're done with that. 2 plus 1 is 3. 2 squared is 4. 4 minus 1 is 3. So we're going to get 1. Let me double check that. 2 plus 1 is 3. All right, so we go over 2, up 1. That's all the points we need because we know that these asymptotes guide us, right? All right. Woo! I think we're done. Let's see what else we've got. So this time, when you fill in, we finally have a hole in the graph, and we'll say there's a hole at x equal -1. That's, you just say where the hole is. All right, you can fill out the rest. All right, we are done. There's a worksheet to do. The key's on the blog. Thank you for joining me. I will see you in class.